right, welcome back. It's me again. And all right, I wore the colors I wore today were because of your lab that you guys are doing this week. I don't know if anybody, it would be Stephen who would have done it. Have you done the chromatography part?
No, I have not.
Oh, okay. Has anybody else done the chromatography part? I've never actually done that. And so I plagiarized and then rewrote that instructions. I think I had the link to the original instructions, but I will be curious. And it's actually been really fun because since I wrote that lab, the leaves have really changed color in the past week. And so you should be able to get some really cool pictures or make yourself a really fun tiara. So your exam is next Tuesday. It will be during this time on Zoom. I will let you, so for right now, I may end up making this 2 hours. It might be 10 until noon, just because I learned last night that some of the students who can print can do the exams much faster. It does give you an advantage. If you don't have a printer, you just write it out on notebook paper. Some of you are doing that anyway with study sets and stuff. And so somebody had asked me, they were worried because they didn't have a printer or their mom couldn't print that day. What were they going to do? And you just write it out on notebook paper. You don't have to write out the questions, just the answer in the order that they're given. But that will be next Tuesday. And so, yeah, it will magically appear on Blackboard at 10 a.m. And the other thing is the video for ions and the notes for ions. Because of the test, I usually start getting into ions this week. And then there's lecture after the midterm. I actually pre-recorded it over the weekend, and so it's there and the notes are there. So if you want to start learning about ions, you can, or you can wait until after the midterm. And then there's a second video because next week after your midterm is we do nomenclature, so naming, so putting the ions together. So you may want to look at the ion stuff over the weekend so you feel comfortable with it. There is the quiz next week and the study set, since the exam is Tuesday, they are on Thursday. So next week on Thursday, I will go through the study set, take like a half hour, I'll record it, and the quiz will be due that day. And then you have a lab. And it does say on the studies, on the syllabus, the lab next week, you actually get a grace period because that you get until, I think, the Tuesday, and then we get back on track. That is chemical nomenclature, and your teacher, I don't like the word anxiety. I got overwhelmed last night because on this platform, when students are taking a test and they have test anxiety, I get a full blast of their face having a meltdown, which was quite fascinating. But hopefully you guys will be much calmer. The other note I have to myself is if you have any late assignments, so some of you late labs, late study sets, everything has to be in next Tuesday, and then they become a 0 on Blackboard. So on Lab 2, it is specifically also Lab 2. If you got less than a 12 on that lab, find the time this week to come in to my office hours and go over it or work on it and resubmit it. There's been like 3 people who have done that and they got it. And so the math is a significant part of the first midterm and this whole term. And then the other part is what this whole study set was about. All right, the test will be show your work. Last night, a couple of people got done in an hour. And traditionally, this class does test much more efficiently. So I anticipate that most of you will be done in an hour, but you will have over an hour grace period because of the atmosphere. Yeah, so just make sure you have a quiet place to do your test. All right, let's just go through this. And somebody asked me this. So redo your study sets, redo your quizzes. That was another comment. I sometimes write comments to you whenever I look at the study sets. I haven't, but on labs and quizzes, I will either write a comment in Blackboard or I actually can write on your quiz. So sometimes I'll actually write the answers. So like this quiz, that's probably what I would do. If you don't get a perfect, if you don't get a 6 out of 6, I think that's what they're worth. You would want to go in and view your quiz and you'll see random blue marks and stuff on there of me trying to write on a computer screen. Yeah, so please be aware of that. If you write a comment back to me, I won't see it, so you would just have to email me. There is also extra credit that's posted, and that would be due Tuesday. If you do it before the test, it's really good practice, and you can absolutely come and ask me if you did it right, but you do have until the 11:59 deadline. The exam, though, is timed, is a limited time, so please be aware of that. I think that's all I got for right now. All right, so element name, S is sulfur. Oh, so go back and do your study sets, do your quizzes, do this practice, go over your notes. I had a student who took the whole 200 sequence with me, and in 221, he was always the slowest test taker. He did fine. He got a solid A each term. He got 103% in the third one. And he said what changed for him was he went back and watched all my videos again, and I gave him a blessing for doing that because I was like, even watching me once, I can't imagine. But he was the only A on the first midterm, and once we went into this format, and then everybody else started watching the videos a second time because they found that once they already understood the information, going back and listening to it, that actually helped to fine tune all these little pieces. And before we were in this format in 221 in the winter, he was always my slowest test taker, my slowest quiz taker. He was always the last one done. And then once he started changing how he approached it and really preparing, he went back and redid all the notes, redid study sets. He was always the first. He was done in half the time. Whereas everybody else was pushing the deadline of when the exam was due. So something to consider. If you are prepared, you're going to be fine. All right, and I'll have my usual office hours. So atomic number for sulfur is 16. So again, that is just the number on the periodic table. This chart needs to be all whole numbers. So keep that in mind on your quiz. This chart is all whole numbers. Mass number, you have to go with mine, 35. This is an unstable isotope. We used to work with it. It's how DNA was labeled. So it's not that number on the periodic table. Protons are 16. Neutrons are subtracting the 35 minus the 16. And electrons are 16. All right. If we add these two together, the 18 and 22, we get the mass number. The protons give us the atomic number. Number 18 is AR, which is argon. It keeps showing up. And the full symbol, you can show the 40. You can show the 40 over 18. All right, the next one. If you subtract the 80, you do get 56. And so that would be atomic number 56. So the protons and the atomic number are always going to be the same. And 56 is Ba, which is barium. We're going to do more columns over here with these because we know more stuff now. And then it is number 136. So again, don't do this unless I've done it. But I may have done it. I did not do it on your quiz. I may have done it somewhere else. If this had been 54, just pretend, if that had been 54, it means that it lost 2 electrons. This is kind of a segue into ions, which is where I know I'm going. that would mean this would have a +2 charge. So the charge only happens if the electrons have changed. All right, I want to add 2 more columns, and that is, because these are the most asked questions, the valence electrons. The valence electrons are key because the valence electrons are after the noble gas. Noble gases are called noble gases because they're stable. They're not royalty, they're just stable. Very different from royalty, right? The valence electrons are the reactive ones. And this is chemistry, and so it's a study of chemical reactions or transformations. So for sulfur, you're just going after the noble gas. So if neon is 10, then after 10, we need 6 electrons. So the answer would just be 6 valence electrons. For argon, again, you can say it's there. You can say 0 or you can say 8. The first thing I talk about in the ion video is the Octet Rule, and it comes from that the noble gases have 8 valence electrons. The number 8 comes from that, so the 8 valence electrons for the noble gases. Again, this is in the video, so you can wait till then. Comes from the S's plus the P's are full, so S2 and P6. And by the way, if you printed this before yesterday, and if you did, you didn't look at it, I reposted it yesterday, but there was this whole section down there on nuclear equations, and that was because we did that in my other class and not your class, and I was trying to double dip, and I didn't notice that. So I reposted it yesterday, and so that's not there. But yeah, if you printed like over the weekend, I apologize, just cross it out. You can draw a picture or something. All right, the other thing I wanted to talk about, sorry, I was looking for another color. We'll just do pink again, is the HEO, because that's been a question people have asked. I ran out of room. So again, the HEO you can get just from looking at the periodic table. So sulfur is in the 3Ps. So that's its HEO. Argon also right next to it, 3P. And then barium is down here. It's in the 6th row in the S area. So we'd say 6S. And that's it. That's all there is to it. Oh, I forgot to do barium's 2 electrons, 2 valence electrons after the noble gas. The valence electrons, this 2 goes with that 2. It's going to determine our ion charges. So for right now, up until the midterm, I will give you the charge, and I would change the electrons and you could just give me a charge. So you're losing negative, that makes you positive. What next study set for next Thursday is you learn how to predict the charges from just looking at the periodic table. That's not on your midterm, that's on the next midterm. But it is a huge step. It's like this quantum stuff. The reason we did all the quantum stuff with the electrons is to get to where the ions come from. And the ions are so we can go into compounds and then reactivity and stuff. All right. Subatomic particle with the same mass as a proton, that would be a neutron. Isotopes have the same number of protons. Similar chemical properties to nitrogen. Pick the one that you like: nitrogen, phosphorus, arsenic, antimony, or antimony, or bismuth. So whichever one you want. So you'd write, this is back to the question you'd ask Spencer, you write the full name, so phosphorus. The metalloids or metalloids, these are also known as semi-metals. So that's the name they use now. So the metalloids was an ancient name that was used for them. But period 2 means the second row. There is only one answer, and that is boron. By the way, aluminum is not a metalloid. It is a true metal. Periodic table, how it's arranged like this is not perfect, but this would be boron. The halogen in the third period. This was a question. You are not counting you're not counting 1, 2, 3 and ending up down here. It is chlorine. So there is no halogen in the first period. There's a blank there. And all right. And then this question about copper. So we find copper, and the average is 63.55. That's the average from the periodic table. So based on that, which of these two must be more abundant? The one closer to the 63. So the copper 63. And that's all I asked here. The one we did on the homework, it asked for neutrons. Sometimes I asked for nucleons. So if I'd asked for how many nucleons, you would say 63. But the average on the periodic table is always closest to the most abundant. I would always tell you what the different isotopes are, and then you could figure that part out. All right, and then number 7, we had a question. Oh, all right. This one does want us to do valence electrons and the family name. And this is like a segue again into ions, but cesium's an alkali metal. Teacher can't spell. Alkali metal. So that's in the first column. So that first column's the alkali metal, and they're in the first column. That means they're 1 electron after the noble gas. So cesium, you would have started at xenon, so 1 electron, so 1 valence electron. All right, strontium is an earth metal. The full name of the family is the alkaline earth metals. So again, the term alkali just means basic or the opposite of an acid. They always say earth metal because they're really common in the Earth's crust. And strontium is 2 after the noble gas, krypton. So it's 2 valence electrons. So again, when we get into ions, it's all about, all chemical reactivity is about the valence electrons. And so they're going to gain or lose electrons to become like the noble gas. So these guys are going to lose electrons, is where we go with this, become a +1 and a +2. All right, bromine is a halogen. And argon is a noble gas. So all the families have names. You could Google them and be smarter than me. Those names are ones that we should be familiar with. So for number of valence electrons, so bromine, the previous noble gas would have been argon. So from 18 to 35, that's going to be 17 electrons. So you can say 17 valence electrons. And that is perfectly fine. That's probably the answer. I also hesitate because different videos online, and I mentioned this also, when the D's are full, they become stable, and an old way, they did not count those as valence. Now they do count them as valence, but they don't react. So sometimes you just see it as just these 2 plus these 5. So the S's plus the P's. So you may see this like on the video. I don't know what I did. It was a couple days ago. I would accept either answer. So 17 or 7. And that is why my periodic table has an alternative numbering system. So the A numbers told you just the S's plus the P electrons, which are the ones that react. And then the new way, which most people have the periodic tables that just number 1 through 18, that number at the top of the group tells you the valence electrons. So it's telling you how many spaces it is after the noble gas. So like if I had asked for titanium, we did that one before, it's 4 after the noble gas. So that's why they put it in group 4. So that's an awesome trick, this 1 through 18, to get your valence. So for the noble gas, the valence, there's 3 possible answers that I would take, which means hopefully I don't ask this question for my own sanity. You could say 0. That's like an old way of saying it's perfect. The octet rule goes with the 8 valence electrons, so it's the S's plus the P's. Or you could go with 18. That wouldn't make sense for argon. But so after neon, it's 8 after neon. But if you went to the next one, it would be 18. And so any of those would be possible. Most people go with it's 8. And there is something called, and I talk about in the video, called the octet rule, which is 8 valence electrons makes you stable. As far as your electrons. And so then you become stable, means non-reactive. So every element on the periodic table has already reacted. As soon as they're formed, they react, except the noble gases. The noble gases were not in Mendeleev's original periodic table because they didn't know about them, because they're not found in anything. And then it was analysis of air, they suddenly found something that they had never seen before. I think that was argon, and they called it argon actually means the lazy one, because they didn't know what it was. It didn't react, so that's why they call it the lazy one. Helium means the sun, so when they looked at spectrums of the sun, anyway, and then they found all of them. All right, I think that's all that's on that page. Is there any questions with that? That should also, I wanted to go over this today because that should also help with when you do your quiz. All right. So this page is all about electrons and quantum stuff. So I'm going to pause my recording. I want to give you guys like 10 minutes. You can try it. You can try either answering the questions here. You can try doing your drawings and see how you do, and then I will go over it. Unless there's a question before I stop. Pause. Or you can take a break. All right. So drawing orbitals. So I start with the noble gas. I can tell this is just one of the coolest things that we do is the periodic table had how it was laid out. And this was a separate thing where they figured out quantum mechanics, and it all fit together, which is really beautiful. And now you're part of that mystery. So the noble gas that comes before it, you can't go backwards, so we can't go at argon and go backwards. And so we're here at neon, which is number 10. You come over to 11. And if you're really not getting this, we'll probably get done early. Just ask me for a few minutes before I have to run off to my other class. So you always come down and you're in the S's after it. So numbering your periodic table. So after neon, we're at the 3 S's. S's hold 2 electrons. And then from the 3 S's, in this row, we jump over to the 3 P's, and phosphorus is the 3rd box over. There's also where you can count your electrons. So phosphorus is number 15. Neon was number 10. So 10 plus 5 is 15. So we know we have it right. For iron, we would start with argon. And after argon is the 4 S's. So after 18, 4 S's, and then we go in the 3 Ds, and we count 1, 2, 3, 4, 5, 6 over. So the Ds are just one off the row number. Back to the question Stephen asked me earlier. We are going to write it. The lowest, how we're showing it, is from low energy to high energy. And that's where the HEO comes from. There is an alternative way, which I will show you momentarily, where they show from inside to out. So for iron, they would write argon 3d6 4s2. It doesn't show you as much information that is useful for what we're doing. All right, and then tin is SN, it's number 50. And again, here you can do the numbers. Argon is 18. We want 26 total, so 18, 26. We got it. So for tin, you would start with krypton, go to the 5s. So if you don't understand it, at least say, okay, I start the noble gas, and then the next row, and S's. And then what? Well, after the 5 S's would come the D's. And these would be the 4 D's. And then you're back in the P's. So the S's and P's are your row number. It's the D's that are off. So these are the 5 S's. The 4 D's would stop here at cadmium. And then we'd be in the 5 P's. And we just have 2 electrons. So again, the HEO would be our 5P. So we're showing from lowest to highest energy. That actually answers a bunch of the questions down below. All right, so the box and arrows. S's get 1 line. You can show a box if you like boxes. So that's my 3S. And then the P's, you need to bracket them to show me they go together. So you can bracket like that if you prefer. And these 3 will all be unpaired. They each get their own orbital. Those orbitals are all equal energy. Those electrons are all equal. Those 3 have to all spin the same way. So either all 3 arrows up or all 3 arrows down, depending on how your day's going, I guess. All right, 4S, just 1 line with 2 arrows. And then the D's, you show all 5 lines. That comes from SPDF, so 5 for D's. And then each one gets 1, gets us to 5, and then one of them gets a partner. So that's 3d6. You don't need to label underneath there because it's right next to it. I just do it when I'm teaching. All right, 5s, 4d, all of them are full. And then the P's. And these 2 can be in any orbital, but they spin the same way. They cannot be together. Do y'all get it? Y'all got it? This ends up being, for most students, like the give me on the midterm. It's like, you got it. It's really cool. It's a beautiful part. For those of you going on to 221, it makes the end of 221. It's what we do the last like 2 weeks, where you're tired and you have all these assignments due in all your classes roll really nicely because you're already familiar with this. In 221, we just go into some of the math actually behind this, which is really fun. All right, unpaired electrons. So this would have 3 unpaired, 4 unpaired, and 2 unpaired. So it's how many arrows don't have a partner. So the unpaired are arrows with no partner. So a solo arrow. It's not how many holes or empty spaces, it's how many unpaired. And then the HEO is the last piece. So 3P, 3D, and 5P would be our HEO. I'm going to add one more question, and that is how many valence electrons? So again, the valence electrons is actually really important because it's going to tell us our chemical reactivity. And it's really, you just see it from here. We have 5. So I'll write it here. This has 5 valence. This one has 8 valence. And then this one would have 14. Some people will say 4 because they ignore the D's once they're full. But there you go. That's it. All right. And now we do a bunch of short answer. So the 4D, the thing I would tell you with this question, these would be the fill in the blanks, like on your quiz. Underline, like I do when I'm teaching it. Sometimes I ask electrons, sometimes I ask orbitals. It's not me trying to be tricky, it's just to see if you're paying attention. Orbitals would be 5. These have 5 orbitals that hold 10 electrons. All right. The F maximum electrons would be 14. So you take that number 7 behind me and you double it. All right, next one, manganese. That is Mn. And manganese would be in the 3D. So the subshell means the HEO. That's a question several people have asked. All right, so for number 6, the third principal energy level just means when N equals 3, and that means there are 3 subshells. If N equals 5, there are 5 subshells. They would be called the 3S, the 3P, and the 3D. That's it. I didn't ask for that, but that's what it would be. All right, and this is back to a question, Stephen, that you'd asked me. And once you see the pattern on the periodic table, and it was the last page of the notes kind of had that cheat thing, which you just, being able to do it from looking at your own periodic table is really nice. So my question asked after the 4Ds. So the 4Ds are here from yttrium to cadmium. What comes next are the 5Ps. So you would just find it on the periodic table. So these are the 5Ps, because that's what comes after the 4Ds. So again, the 4Ds are from yttrium over to cadmium. Right, and then number 8, again, from the periodic table, you would find each of these. So the 3Ds are way up here. The 5S's are down here, so they're even higher. And then the 4Fs. So it's not that the 4Fs win this question, but the 4Fs would go here. Actually after 57. And so they're higher than the 6S's, but they'd be lower than the ones after them. So for this question, we would say the 4Fs. And then the 5Fs would go here. They don't show them there, and they're actually into the 8th row. So the Ds are 1 row off, the Fs are 2 rows off. So in the 6th row, we have the 6S's and the 6Ps. In the middle, we have the 5Ds and the 4Fs, for what that's worth. All right, maximum electrons in any orbital is 2. That's the up and down arrow. Valence electrons for phosphorus would be 5. So this is after, oh, it was up here, we did that. So it's everything after neon. Or after the noble gas is what I should have said. All right, so number 11. I thought this was in the study set, but it wasn't. So generic is the halogens are fluorine, chlorine, bromine, and iodine. And so the thing that they have in common is they all end with a P, and more specifically P5. So that's the generic notation that I'm looking for, is they're all going to end with P to the 5th. And a way we denote that is we put an N in front of it, and that N can be any number. So if it's fluorine, it's 2p5, 3p5, 4p5, 5p5, 6p5. All right, so that would be fine for an answer. NP5 would tell you it's a halogen. They will often put the S's with it because they want to show, well, they have to have the S's if they get to the P's. So the N, if you're fluorine, it would be 2s2, 2p5, 3s2, 3p5, and so on. And by the way, the answers are down here in case you go back and do it and or you missed anything. All right, number 12, the halogen in the third, we just did that. That is chlorine. And again, when I ask for the name, I do want you to write the full name out. Chemical properties similar to oxygen, you're picking the same family. So whichever one you want. So sulfur, selenium, tellurium. Sulfur, some people spell it with a pH. I don't really care. All right, 2 3D electrons. That would be titanium. So it would say 3D2. So Ti is titanium. All right, 15 was from my video where I gotta do the fireworks. The Roy G. Biv, red is the longest wavelength. And then past that gets longer and longer, like infrared and microwave. So red is the longer wavelength. Blue would have the higher frequency, so they're always opposite. So blue would have more energy. And that does relate to electrons because, and also with lasers. So most people use red lasers because they're much safer than a blue laser can actually cause some serious damage. All right, gallium is Ga, and gallium is a metal. So that's the staircase. It's not touching the staircase, so it's over here. Yeah. All right, and unpaired electrons, cobalt is CO. So it would end, its CO would be 3d7. So it's going to have 3 unpaired electrons. Because to get to 3d10, it would need 3 more. So our answer would be 3. All right, and then the last two, I don't know why I did 19, but why not? The HEO for sodium would be 3s. So knowing that sodium is Na, it's going to make you a lot more efficient time-wise because you're not searching and hunting. And so sodium's ending with the 3s. And number 19. I thought this was in the homework, but we'll talk about it here because I'm supposed to talk about it. And I don't think I think it was on your quiz and I took it off of there. Yeah, I don't see it on there, so I don't have to worry too much. But which is the smallest? The trend is the largest is as you go down, you're adding shells. So every time you add a layer, it gets bigger and bigger and bigger. So barium and cesium are not going to be the smallest. They're going to be larger. But the weird thing is, as you go across this way, they get smaller. And that has to do with something called the nuclear charge. So strontium is actually the smallest. And as you increase the nuclear charge, so strontium has more protons than rubidium. And so as you get more protons, it actually pulls the electrons in just a little bit tighter. So every electron would be attracted to all the protons. And electrons have a negative, and as you get more and more positive, it's like a picometer difference or 2 picometers difference. Adding a shell makes a huge change because you're adding a whole nother layer. But that is why it is strontium on my answer. My answer is wrong. I wonder why I wrote barium. I think I wasn't looking at a periodic table. And so that should say strontium in my, yeah, strontium in the answer key. Maybe I'll remember to fix that one of these days. All right, that's all I got, unless there's a question for the good of the order. I will stop.